Welcome to This Explainer. Today, we're diving into something that literally keeps our modern world spinning: solar-powered telecom sites, and of course, their massive benefits. When we think of the internet, we usually just imagine it floating up there in the cloud, right? Totally weightless, completely invisible. But actually, there is a huge, hidden physical energy cost to our daily digital connectivity. So in this explainer, we're going to unpack exactly what that costs us and how some really cool new technologies are stepping in to completely transform it.
All right, let's just jump right in with a super simple but honestly profound question. How exactly is your mobile internet powered? Seriously, take a second and think about what physically keeps all that invisible mobile data running in the real world. Every single text you send, every video you stream, every time you scroll through your feed, all of that requires actual, physical, ground-level infrastructure.
And here is where it gets crazy. A staggering 70 to 80% of all telecom emissions don't come from where you think. They actually come from what the industry calls the last mile. We aren't just talking about massive remote data centers out in the desert. We're talking about the actual physical cell towers right in your neighborhood or out in rural areas that are actively beaming that signal directly to your phone. That is a massive chunk of emissions.
Which brings us to our first main topic: telecom's hidden energy consumption. Now, while networks use some incredibly smart software to optimize how data flows, the physical support equipment sitting at the base of the tower tells a very different story.
To get a handle on this, operators use a very specific metric called Site Energy Efficiency, or SEE for short. Think of SEE kind of like your car's fuel efficiency. It measures the ratio of the energy that's actually being used by the active computing equipment to process your data versus the total energy being sucked up by the entire site. This is a real game changer because it helps operators clearly see how much of their power is doing the heavy lifting of computing versus how much is literally just being wasted on keeping the machines cool with giant air conditioning units.
So what happens when those towers are off the main power grid? Let's look at the harms caused by diesel generators. See, in off-grid or weak-grid areas all across Africa and Asia, these towers simply can't rely on a stable grid, which forces them to fall back on localized, dirty power.
Basically, we're looking at a huge threefold problem with these legacy power setups. First off, they pump out massive operational greenhouse gas emissions, what experts officially categorize as Scope 1 and Scope 2 emissions. Second, they absolutely drain operating budgets. Think about it. You've got the constant need to truck in diesel fuel and perform regular mechanical maintenance on these generators. And third, they rely on traditional lead-acid backup batteries. When those degrade, and they always do, they create dangerous environmental hazards and toxic e-waste. It's just a mess.
But hey, there is incredibly good news here, which brings us to our next section: the solution through solar energy. By tapping into local renewable energy, the telecom industry is completely revolutionizing that last mile we talked about.
When you put these technologies side by side, the difference is just staggering. We are trading the old, dirty way of diesel and lead-acid batteries for a green tech revolution. We're talking solar arrays and intelligent lithium-ion batteries. And the real secret weapon here? These high-density lithium-ion batteries can safely run way hotter than legacy batteries. That is a massive deal because it dramatically slashes the need for those power-hungry air conditioning units at the tower site. Less cooling means way less wasted energy.
But it's not just about saving the environment. Let's look at the economic benefits of solar sites. Because transitioning to green technology isn't just an environmental mandate anymore, it is a remarkably smart business move. The financial reality over time is crystal clear. When you analyze the total cost of ownership for these off-grid power solutions, relying on diesel creates this skyrocketing, compounding cost over the years. However, when you combine battery storage with solar power, the upfront investment pays off incredibly fast. Over the long run, it becomes significantly cheaper. The absolute biggest takeaway from all that data is this: solar-powered telecom sites can be nearly 50% less expensive than fossil fuel-powered sites over their operational lifetime. Seriously, let that sink in for a second. 50%! Going green isn't costing these telecom operators more money, it's actually saving them up to half of their power expenses over the life of the tower. It is a total win-win. So let's ground this in reality and look at some real stories of success. We aren't just talking about theories on a whiteboard here. This solar transition is actively happening right now with massive success all across the globe. Let's kick things off in Bangladesh by spotlighting Robi, which is a massive mobile network operator over there. They've built out over 1,600 solar-powered base stations.
Combined, these generate 8.4 megawatts of clean energy output. But honestly, the coolest part is that these telecom towers don't just run cleanly, they essentially act like mini power plants. Through a system called net metering, they are actually feeding their excess unused renewable energy straight back into the national power grid. How amazing is that?
Another incredibly inspiring real-world application is the ABC mini-grid project in the Democratic Republic of Congo. This is a joint venture between Bbox and Orange. Over there, 85% of the tower's energy is generated directly by solar panels. But it goes a step further, and this is where it gets really good. It takes the surplus clean energy generated by the tower and supplies it directly to the local community. So this single solar tower is simultaneously powering digital internet access and bringing vital, life-changing electricity to the surrounding households.
Finally, let's check out this case study from Uganda, which is heavily supported by World Bank initiatives. By installing off-grid solar devices directly onto the transmission masts themselves, they are solving a critical, real-world infrastructure issue. This specific setup ensures that internet and phone services remain completely reliable, even when the main national power grid fails or experiences a blackout. So it's about resilience and staying connected during emergencies, just as much as it is about sustainability.
To wrap up our explainer today, I want to leave you with a final, somewhat provocative thought. What is the carbon footprint of your digital life? The next time you stream a video, send a quick photo to a friend, or even just load a web page, take a split second to picture the physical, real-world towers making that possible. Because if we really want a connected future, it can't just be about faster speeds or better coverage, it absolutely must be a sustainable one. Thanks for exploring this with me.